Welcome, geometry students, to section 3.8, slopes of parallel and perpendicular lines. We already kind of talked about different types of lines, slope, intercept form, point slope form. Now we're going to talk about what it means to be parallel and how do we determine that. So let's go ahead, and we have guided notes here, so follow along for those that are at home. Slopes of parallel lines are equal. Okay, so they are the same. If you want to watch the same, that's fine too. So I'll give an example here. If we have y equals, let's say negative 3 over 5x plus 2. If we were to have a parallel line would be something like this. Y equals negative 3 over 5x. And then the y-intercept does not matter as long as it's not the same as plus 2. So I can make it minus 3. Now, one thing you got to keep in mind, the number in front of x, the coefficient of x, this is your slope, and these need to be equal for them to be parallel. So these are parallel. Okay, moving on. Vertical lines are parallel to other, obviously this is vertical lines. So if it's a vertical line, it's got to be parallel to other vertical lines. For example, an example of a vertical line is x equals negative 3. This would be parallel, and that's the symbol for parallel right there. Dramatic zoom. Equals x equals, I don't know, let's say 5. Man, I'm really on this negative 3 and 5. I've chosen that number. Let's change it. There's other numbers out there than 3 and 5, so let's make it negative 7 and then positive 9. Really sticking with the odd numbers, but there's only 9 to choose from. 10. Horizontal lines are parallel to other horizontal lines. Now, what is the equation of a horizontal line? Well, an example of a horizontal line would be y equals 4. That would be parallel to y equals 5. Okay, and then again, those two little lines that I've drawn here, I'll highlight this for a second. So these little lines here, this means parallel. Okay, so that's parallel. Okay, now let's get into an example where we actually have to determine the slopes. The question is L parallel to M? Now, most of you are probably looking at this and like, yeah, they look parallel. It doesn't look like they cross. Definition of parallel means they don't cross. So how do we determine this for sure? Well, we'll need to find the slopes of both line M, that's this guy, and line L, that's this guy. How do we find the slope? Well, we know the slope is equal to the rise over the run, the change in the vertical over the change in horizontal, the change in y over the change in x. That's the ratio. So if we're going to find the slope of M, and actually M is just the symbol for a slope, so I should say line M here, put in a box, and then I say y2, that's my negative 4, minus y1, over x2, negative 1, minus x1, and that's negative 3. I'm going to put a little arrow here, and that equals negative 7 over, what is that, positive 2, so negative 7 over 2 is my slope for M. Okay, so that's that slope. Negative 7 over 2. I got to do the same thing for L. Now, normally the equation is y2 minus y1. I went ahead and labeled this for you x3, y3, x4, y4, just to show you it doesn't matter what they're labeled. We just take the difference in the y's over the difference in the x's. So now we're on to line L. I don't know why I put a cursive L there, but that's fine. Right here. So line L, and we do y4 minus y3 over x4 minus x3. That gives us negative 4 minus 5 in the top, and in the bottom we get 2 minus a negative 1. Okay, what does this equal? We get negative 9, and I already see that we're in trouble for this to be parallel, and then we get 3. That's the same thing as negative 3. So negative 3 over 1, or just negative 3. Clearly, these are not parallel because they are not the same. They have to be the same in order to be parallel. So if you were just to say, oh yeah, they look parallel, you'd be wrong. Write an equation of a line parallel to y equals negative 3x minus 5 that contains this point. Now, I'm going to show the point slope method. Okay, I think this is the best method. So using point slope, it's very easy. Okay, so this first step is to label the points. Label the points and slope. So in this case, there's only one point. Oh, I should say and determine slope, just in case you don't have the slope already. And determine slope. Oh, I should say parallel slope because we're trying to find a parallel slope. And determine parallel slope. Okay, so let's take a look here. First, label the point. So the point it goes through is -1, 8, so that's x1 and y1. Very important you call it x1 and y1 if you're going to use point slope form, because clearly there's an x1 and a y1. Next, write an equation of a line parallel to this. So this is the line we're supposed to be parallel to. We have to determine the parallel slope. So we see that it's currently -3 for this line. So we need to match that. It also needs to be -3. So the three pieces of information we have is the slope is -3. We know that x1 equals -1. And then we know our y1 equals +8. Okay, sorry, that negative sign's a little annoying to me. I want to make sure it's correct. I'm sure it was bothering you too. Now, second step, pretty easy. We just plug it in. Plug into point slope. Okay, so we're just going to take all these values and we're going to replace every one that we know. So we're going to take y minus 8 equals, then we have -3 times, I'm just using blue here, I guess that's good enough, x minus, and then we have -1. Now, anytime we have minus and -1, we're going to want to change that. I'm going to change the color just so you see what we plugged in. Give me a moment. So we had y minus, what was it again? 8. And then we had minus -1. Okay, so this is going to turn into y minus 8 equals -3 times x plus 1. And we are done. That's all there is to it. Now, this is in point slope form. So if it asks for it to be in slope intercept form, then we're not done. But I just want to be very clear that this is an equation of a line that's parallel to the other one. So all we need is to label those points and then plug it in and we're done. Again, if it's asking for slope intercept, it's a pretty simple process. Let's see, converting to slope intercept. And that's basically solving for y. So what we do is we're trying to get y by itself if we're solving for slope intercept. Okay. And let me just write that in blue. So we'd solve for y. So we do y minus 8 equals -3 times x plus 1. We distribute first, you get -3x, and then what is that? -3 equals y minus 8. And then we would add 8 to both sides, and we would get, for our final answer in slope-intercept form, y equals -3x plus 5. Hey, it's our 3 and 5 again. What do you know? Anyway, so these are the same line because they are just in different forms, but is parallel to this guy. Okay, I'm going to erase that because that's ugly. But that is the same line. One's in point slope, one's in slope intercept. So it just depends on what you want. In my opinion, going from point slope into slope intercept is very easy to do. Okay, so that's this is our introduction into parallel lines. I'm going to say perpendicular for another video. It's not much more difficult, but there is one additional step we need to consider. So I will see you next time in part 2.